So in today's video, we're going to talk a little bit about higher order derivatives. And so we know that the derivative is kind of just an operator, right? It's something that you can apply to a function to get kind of another function out or to get an expression out. And, with that in mind, we can just apply the derivative operator multiple times to a function and we will just get another expression out. I mean, that's assuming that we're differentiable, but again, we'll talk about differentiability a little bit later on. And so let's suppose that we have some function y equals f of x, and we kind of take the derivative of that function. So we get dy by dx over here. Then we can just go ahead and apply the derivative operator again to this function to get d squared y by dx squared. So this is just the second derivative of y with respect to x. That's how you would read this. And it's just the same thing as applying the derivative operator onto dy by dx, right? So we're kind of just taking the derivative of the derivative of x, or we're taking the derivative of the derivative of y, essentially. So we're just applying the derivative operator twice. And there's another notation for this as well if you have it like in f prime of x notation. So this is the derivative of f prime of x essentially. And if we apply the derivative operator to f prime of x, then we get f double prime of x, or f prime prime. And over here, as you can notice, this the number of prime marks, I guess. This kind of just indicates the order of the derivative, right? And so with that in mind, I mean, we can imagine that if we were to take the third derivative, for example, that would be f prime 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 of x, or f triple prime of x. Or if you were to take the fourth derivative, then you'd have 4 prime marks. But sometimes, if you wanted to take like the 10th derivative, you're not just going to sit down and write out 10 prime marks. So what they'll usually denote that by would be like, for example, f to the 10th, right? It looks like it's f to the 10th power, but this just indicates the order of the derivative of x, right? And so these are all, different notations. And for this notation over here, you would say maybe like if you wanted to take the third derivative, then you'd get d3y by dx cubed. Or you just read this as the third derivative of y with respect to x. And so what we're going to do is I'm actually going to try to illustrate an example of how we can use this notion for this particular function over here. So here we have y equals f of x, which is equal to 1/2 x to the 6th plus 2x cosine of x. And so what we're going to do is we're going to first of all determine dy by dx. We're going to just take the first derivative of this function. And so what we can do is we can use the power rule for this first term over here. So we'll get 6 times 1/2. So 6 over 2x to the 6 minus 1, which is 5. And then over here we have 2x cosine of x. We know that we have to use the product rule. So the derivative of 2x, we know that that's just going to be 2. So plus 2 times the first function, which is cosine of x. And then we get 2 times the second function. And then here we get the first function, which is 2x, times the derivative of the second function. The derivative of cosine of x, as you may recall, is negative sine of x, times negative 2x, we get negative 2x times sine of x. And we can just go ahead and simplify this term up here. We'll get 3x to the 5th plus 2 cosine x minus 2x sine x. If you don't understand how we got this, then I encourage you to review the different rules for derivatives and the derivatives of basic functions. And so now that we have this expression over here for f prime of x, we can go ahead and just take the derivative of this expression again in order to get f double prime, or in order to get the second derivative of f. And so we can go ahead and do that. We can just I'm going to write it like this. We can kind of just apply the derivative with respect to x of this function over here, and then this will just be equal to f prime of x, so f double prime of x, right? Because we're just taking the derivative and we're applying it to this new expression. Like this over here is just some function, so we can obviously take the derivative of this function, right? Because, we're just inputting a function into the derivative operator. And so if we were to take the derivative of this, again, we can use the power rule over here for 3x to the 5th, and we'll get 3 times 5, which is 15, x to the 5 minus 1, which is 4, so 15x to the 4th. The derivative of 2 cosine of x, we can just keep the constant out, and that'll just be the derivative of cosine of x, which is negative sine of x. And of course, we can't forget to multiply by the 2 at the end, so we get negative 2 sine of x. And then over here, negative 2x sine of x, again, we just use the product rule. We know that the derivative of negative 2x is just going to be negative 2. And we know that and then by the product rule, we just multiply by sine of x, so we get negative 2 sine of x. And then we would again multiply by, or sorry, we would actually add the first function times the derivative of the second function. So the first function is negative 2x, and the derivative of the second function, we know the derivative of sine of x is cosine of x, so then that would be our expression right over there. And we can simplify these two terms over here. We would get this to be equal to 15x to the fourth minus 4 sine x minus 2x cosine x. And so this right over here would be our final answer. And so essentially the point of this is just to say that you can take higher order derivatives. And in fact, I encourage you to go ahead and try to take the third derivative and the fourth derivative just to get some extra practice. And just keep in mind, it's essentially just applying the derivative operator onto the derivative of a function multiple times. So just consistently keep applying the derivative operator onto a function, and that's how you get these higher order derivatives.